In this video, you are going to learn about stretches of periodic functions. There are two types of stretches. The first is vertical and the second is horizontal. So, for vertical stretches, we use y equals a trig theta. Trig can stand for sine or cos, depending on the question. Take note that when graphing, same rules apply of the periodic function. Like when a is greater than 1, the graph is expanded, etc. The only difference is that the amplitude of each function is a numerical value of a. So as you can see, when a equals -4, you change it to a equals 4 because you cannot have a negative a value. The vertical stretches depend on the a value. So for the first example, we have f of x equals 2 sine x. Now it says state the amplitude and the period. So the amplitude is the same as the a value. So the amplitude would be 2. And the period, since it is not affected, will be 360. Now, part B says obtain the transformation. So since there's only one transformation, there's a vertical stretch of a factor of 2. Now, it says graph the function. Now, our normal coordinations for sine would be 0, 0, 90 and 1, 180 and 0, 270 and -1, and 360 and 0. So, since we have a change, it should be a change of 2. So all the y values will be multiplied by 2. So this will change to 0 and 0, 90 and 2, 180 and 0, 270 and -2, and 360 and 0. So take note that only our 90 and 1 changed and our 270 and -1. Now, if we were to graph this, it would look like, so 360 at the end, and then we divide it by, try to divide the parts by 2 if you don't have a proper graph. Okay, so our first one is 0, 0. Then we have 90, 180, and then 270. Okay, 90 and 2. So usually we would be at 1 and -1. But since it changes by 2, we have to put 2 and -2. So it'd be 0, 2, 90 and 2, 180 and 0, 270 and -2, and then 360. So as you can tell already, you can see the stretch that has been made. And that is what our graph will look like. Okay, now we change to horizontal stretches. Horizontal stretches can be represented by y equals trig k theta. Remember, trig can be sine or cos depending on the question. So just like before, when graphing, the same rules apply to the periodic function. The only difference is that the only feature of a period function affected by horizontal stretch and compression. So, the horizontal stretch depends on the k value. In order to find the period, you need to use the formula P equals 360 over k. So, for example, we have y equals cos 3x. It says state the amplitude and the period. So, the amplitude is unaffected, so it will equal 1. As for the period, we use our formula 360 over k. Now the k value is 3. So we will do 360 divided by 3. which will then give us 120. Now it says obtain the transformations. So there's only one transformation that's happening, and that is a horizontal compression by a factor of 1/3. You need to take note that the K value is a reciprocal when you're stating the transformation. So we have a horizontal compression of 1/3. Now it says graph the function. So for our coordinations we have 30, 60, and 90, and then 120. So since the amplitude is unaffected, we will still have 1 and -1. So when we plot the points, it's 0 and 1, 30 and 0, 60 and -1, 90 and 0, and 120 and 1. As you can see, it is compressed.